It is one of the most powerful and versatile self-propelled artillery systems in the world. Capable of firing 3 rounds in under 9 seconds, the German Panzerhaubitze 2000 howitzer is also one of the artillery guns with the most impressive fire rate in modern warfare. The enormous mobile howitzer might be confused with a massive tank at first glance due to its thick armor and rotating turret configuration. Still, the 155mm gun mounted on the armored vehicle can deliver a devastating barrage of indirect fire that can reach up to 40 kilometers. The unprecedented artillery gun made its debut during NATO's incursion into Afghanistan in the early 2000s, covering its International Security Assistance Force troops and obliterating enemy positions from a safe distance. The Panzerhaubitze 2000 was so crucial to the efforts in the region that it soon gained the nickname the Long Arm of ISAF. Despite Germany's current policy of avoiding arms races, the device clearly shows that they are still capable of producing revolutionary weapons. And as new conflicts erode around the globe, the Panzerhaubitze 2000 is sure to deter even the most vicious warmongers from attacking Germany and its allies. Developed by Krauss-Maffei Wegmann, or KMW, cooperatively with the leading subcontractor Rheinmetall Lynx system, the 155mm self-propelled howitzer Panzerhaubitze 2000 was created as a modern artillery solution for the German army and as a replacement for the aging and increasingly unreliable PZH-155-1. The powerful 52 caliber rifled gun is chromium-lined for its entire 8-meter length and includes a muzzle brake on the end. This weapon also uses an innovative modular charge system with 6 charges and a capacity to store 60 rounds at any given time. The formidable loading system developed for the Panzerhaubitze 2000 is part of what makes such a high rate of fire possible. Besides the modular charge arrangement, the primer is loaded separately via a conveyor belt, and the total loading, laying, and clearing are entirely automated. A modified version of the Wegmann's Leopard 2 was chosen for the chassis of the mobile artillery unit and the turret where the gun is mounted. That is the main reason why the Panzerhaubitze 2000 resembles an oversized tank. However, that's where similarities end, as the howitzer is equipped with specialized continuous tracks and suspension systems that give it superb cross-country performance. The weapon's propulsion system is located in the front of the hull. It consists of an 8-cylinder direct injection supercharged MTU MT881 KA500 diesel engine with a 4-speed Renk HSWL 284C gearbox. The hull is also heavily reinforced to protect the unit and crew from enemy counterattacks. This design was modified after its first iteration in the early 2000s, and the newer version, developed in the 2010s, has thicker armor and can fire a more comprehensive array of ammunition. The turret in the latest Panzerhaubitze 2000 also includes a phased array radar to measure the muzzle velocity of each fired shell. This data can be automatically sent to strategic headquarters for targeting adjustments. The initial intended maximum range of the howitzer was 30 kilometers. However, the artillery solution overtook its own design limits in May of 2001, when during a series of test firings for the Hellenic Army, the PZH-2000 fired 20 rounds, all to ranges exceeding 40 kilometers, with a maximum distance of 41.8 kilometers. Conventional howitzers have an approximate range of just over 14 kilometers, making the Panzerhaubitze 2000 a significant breakthrough in modern artillery development. The unique range capabilities of the German solution were further reinforced in November of 2002 during live firings in Sweden, where similar ranges were obtained using Rheinmetall's new long-range RH-40BB ammunition. The impressive ranges were obtained using M2000BB Essagai shells from the Denel Corporation of South Africa, in combination with the Rheinmetall DM72 modular charge system equipped on the howitzer. Eventually, a staggering range of 67 kilometers was achieved using M2005 VLAP-assisted projectiles. To put it in perspective, a Panzerhaubitze 2000 could engage targets in New York City all the way from Trenton, New Jersey, while remaining virtually immune to artillery counterstrikes. The German army initially requested 450 units, but it has since reduced the demand to 260 as the government decreased its military budget in 2012. However, production of the unique howitzer continued as the Italian, Dutch, and Greek armies became highly interested in buying the German artillery solution. Greece acquired 24 units, while 70 were delivered to the Italian army thanks to a German-Italian co-production program. The system entered service with the Italian army in June of 2007 and accomplished initial operating capability in October of 2008. Today, the Panzerhaubitze 2000 is an essential part of Italy's artillery divisions. The Dutch army signed a contract to purchase 57 units, which later decreased to 39, and completed deliveries by 2010. The remaining 18 units were offered to the Australian army, but were rejected. Due to its outstanding range, rate of fire, and reliability, German commanders are considering the gun's potential as a naval artillery solution. Thus, a Panzerhaubitze 2000 turret has been successfully mounted on the deck of the German Navy F-124 frigate Hamburg. No further details regarding the howitzer's gun use as a naval weapon has been revealed. Still, according to preliminary reviews, the gun is more than capable of performing adequately while mounted on the deck of a warship. It wouldn't take long for the groundbreaking artillery system to go from the testing grounds to the battlefields. As NATO began a large-scale incursion into Afghanistan in the early 2000s to root out the Taliban extremist forces hiding in the region, the howitzer would become a significant advantage for the International Security Assistance Force. In September of 2006, the Panzerhaubitze 2000 would complete its first live-fire combat operation, serving for the Dutch army in Afghanistan as part of Operation Medusa. During these preliminary tasks, 3 Panzerhaubitzes provided artillery support from over 30 kilometers away to NATO task forces as they attacked key Taliban positions. The system continued being used during the 4 stages of the ISAF deployment from 2006 to 2014. During that time, the weapon's formidable capabilities earned the admiration of Allied forces deployed across Afghanistan. Still, some significant flaws also became apparent. Despite its initial fantastic test results, the gun was heavily criticized by the Dutch army as the delicate automated reloading systems were designed for use in Europe and could not cope with the high level of dust in Afghanistan, leading to malfunctions and mechanical mishaps. Additionally, the gun's drastic increase in armor during the development of the second iteration resulted in significant issues, including the need to always keep the system in the shade unless actually firing. If this wasn't done routinely, the internal chambers would overload, risking the integrity of the system and the crew operating it. Ironically, the howitzer's automated temperature regulation system didn't seem to address the issue, nor did the fact that the gun needed to be warmed before the operation to avoid a considerable cold gun effect that drastically affected the performance and rate of fire. To solve the cold gun problem, unique warmers had to be used by the Dutch army to prepare the artillery units before every firing procedure during cold days and nights. The heavy armor plates and the hefty track and suspension systems also led to another shortcoming that caused civilians to come into conflict with NATO troops, as the howitzer would completely destroy local roads as the unit moved from one location to the next. Putting aside the flaws presented when operated in less than ideal conditions, the Panzerhaubitze 2000 remains one of modern warfare's most remarkable artillery solutions. To this date, more and more of Germany's allies are requesting access to the weapon. Thanks to its lightning-fast rate of fire and unprecedented range, it might just make the difference between failure and victory in conflicts to come. While tanks have evolved to become lighter over time, they are arguably more powerful now than they've ever been, and the Rheinmetall Lynx is on the leading edge of the transformation. If it's true that mission success depends on swift adaptation to rapidly changing threats, then the Lynx has already succeeded. A concept born in 2015, the Lynx modular light tank has branched into several specialized variants, and more are underway. The German firm claims its infantry fighting vehicle is, quote, radically different and uncompromisingly innovative. With its modular design, freedom of action, survivability, and adaptability, the vehicle is slowly but surely securing a place among NATO's favorites. In fact, the model is a top candidate to replace the proficient Bradley fighting vehicle in the coming years. Armed with a mighty Lance 2.0 turret, enhanced vision gadgets, or with ambulance appliances, quote, "A Lynx is always a Lynx, no matter how it's configured." As military operations grew increasingly complex and hard to predict on the 21st century battlefield, an innovative vehicle concept was born to fill the gap in the market. Designed by Rheinmetall Lynx system, part of the company's vehicle systems division, the Lynx was conceived as a family of armored fighting vehicles. Rheinmetall started the endeavor in 2015 as a private venture, aiming to provide customers with a modern infantry fighting vehicle that could both counter emerging near-peer threats and conduct asymmetric or peacekeeping operations. According to the Dusseldorf-based company, the series is, quote, "at the forefront of a new trend in IFV design." In truth, armored vehicles will gradually evolve to reduce complexity, as well as lower unit and through-life costs. A key principle of the concept is the integration of proven subsystems, which feature a high technology readiness level that not only reduces development time and cost, but also technical risk. According to the manufacturer, the platform offers maximum freedom of action, or move, sense, and strike capabilities. As such, Lynx assures outstanding mobility, data gathering, analysis, and dissemination, and flexible and effective response to battlefield threats. Within 5 years from the initial idea, the elaboration, conceptualization, and development phases were completed, up to the point of the first successful sale. In June of 2016, the Lynx was introduced in its lighter configuration, the KF-31, at the Eurosatori Defense Exhibition. 2 years later, the KF-41, a slightly larger but considerably heavier vehicle, was also unveiled at the event. During the exhibition, the KF-41 was displayed in 2 configurations. First, as the classic IFV, with the vehicle armed with a Lance 2.0 turret. Subsequently, it was reconfigured into a command variant. By the fall of 2020, the first interested country to procure what Rheinmetall called, quote, "the most advanced IFV to date" was Hungary, a NATO member. After that, the Hungarian government and the Rheinmetall Group signed the contract for a joint manufacturing project. During this time, the Lynx family's flexible design branched into several purposes. In the company's words, quote, "Never has the principle of modularity been pursued so systematically. The latest developments open a multitude of new possibilities for creating modular vehicle platforms." Central to the Lynx design is its modular configuration. The concept is separated into 2 primary parts, consisting of the basic chassis and specialized mission and role equipment. All Lynx variants are designed around a standard drive module of a conventional layout. Built around a sponson-shaped hull, the so-called light tank features a shallow glacis and angled belly plate. And at the front, it has the driver compartment to the left and a Liebherr D9612 diesel engine to the right. When fitted with a turret, there's a fighting compartment in the missile section. Also, a dismount compartment with access via a power-operated ramp is housed at the rear. This rear crew compartment is a mission-neutral space, fitted with C-rails and universal fixing points, providing flexible configuration for specific equipment. Finally, the exhaust and cooling are routed to the rear, thus reducing the Lynx's thermal and acoustic signature. Final drives are mounted at the front, while the rear holds toothless idler sprockets with track tensioners. As for the running gear, 6 road wheel stations are located on each side. The wheel stations guide lightweight steel or segmented rubber band type track and are mounted on a suspension system consisting of swing arms. Equipped with conventional torsion bars and super shock damper systems, the setup is both reliable and cost efficient. In addition, an assortment of mission kits can be installed at the front. For instance, the IFV kit comprises a turret fitted to the roof, and an armored personnel carrier module features a roof plate for an array of vision devices, including night vision alternatives and a remote weapon station. The combat support vehicle, custom made for the Australian military, features a prominent design particularity. Apart from the turret's removal, the rear was altered to provide a lowered load bed for cargo. Moreover, a 5-ton capable crane was fitted in the center, with additional fuel tanks and storage volume housed below the load bed. The Lynx can take up command and control, armored reconnaissance, repair and recovery, and ambulance roles, among others. and the transformation from one configuration to another can take place either near or in the field within 8 hours. Notably, several other variants are underway, including a mortar carrier with a 120mm mortar, a C2-C3 vehicle, and an air defense variant. The machine is fitted with several subsystems to facilitate maintenance. The KF-41 is a shared mechanism in the Puma and Ajax vehicles, while the driver's station was taken from the Kodiak. Besides, the tracks are identical to the PZH-2000s, and the Liebherr engine is widely used in the industry. As far as mobility parameters are concerned, they vary according to each configuration. Generally speaking, maximum road speed reaches 70 km per hour, gradability is at least 60%, and side slope traverse capability is 30%. Moreover, the vehicle has the ability to climb a 1-meter vertical obstacle frontally, cross a 2.5-meter trench, and an unprepared fording depth of 1.5 meters. With 900 liters of fuel, the range expands up to 500 kilometers. Also, the Lynx's protection can be scaled according to each specific threat. Its ballistic steel armor was crafted for anti-tank weapons, medium-caliber ammunition, artillery shrapnel, and bomblets. However, the specifics remain classified. There are several available kits, including the standard Mounted Combat Operations, or MCO kit, for protection against similarly armed opponents, featuring an advanced passive component as well as active protection systems. In contrast, the Complex Urban Environment, or CUE kit, excludes active components. Furthermore, a specialized kit for air transportation is understood to protect the vehicle so that it can be deployed straight from transport aircraft. The AMAP ADS active protection system also provides additional active protection for shaped charge warhead attacks, while an assortment of passive and defensive aids include ROSI, or Rapid Obscuration System, Laser Warning System, and Acoustic Shot Locator System, all integrated with the Lance turret. And besides the heating and cooling ducts, the light tank counts with nuclear, biological, and chemical filtration combined in an environmental control system. The 2016 Lance turret can fit an autocannon of 30 or 35 millimeters, as well as a 7.62mm Rheinmetall machine gun RMG capable of 800 rounds per minute. Plus, the vehicle can also be fitted with an anti-tank guided missile launcher. As for the 2018 version, it features the Lance 2.0 turret, with flexible mission pods to the sides, providing specialized capabilities. In 2022, the company announced a fire support variant of the KF-41, armed with a 120mm gun. The next-generation vehicle will merge a test-and-tried turret concept and the smoothbore cannon with the classic Lynx KF-41 chassis. Offering a high-performance solution, the Lynx 120 not only harbors vast growth potential, but also an assured overmatch capability. Additionally, the platform conforms to NATO standards and has drawn the attention of several countries, including the Czech Republic, Slovakia, and the United States. In fact, the model is considered a primary suitor to become the replacement for the Bradley fighting vehicles. However, the U.S. Army rescheduled the optionally manned fighting vehicle program and rearranged requirements, as well as the acquisition timeline. From mid-2022 until 2027, many companies within the industry will carry out the last phases of detailed design, prototyping, and low-rate initial production, including the American Rheinmetall vehicle. And full-rate production of the new armored vehicles is expected by 2030. The German armed forces have been operating the successful Marder infantry fighting vehicle, known as Puma IFV, for over 40 years, and it has already begun to show its age. Not wanting to stay behind other nations' IFVs, the German army has been slowly replacing it with the Puma, a next-generation vehicle that has proved the perfect companion to Panzer Grenadiers and Leopard tanks. Equipped with state-of-the-art interchangeable armor plates that can make it as heavy and bulletproof as a Russian T-72 tank, the Puma also lives up to its name by reaching speeds of more than 70 kilometers per hour and striking the enemy from where it least expects it. Armed with a devastating cannon, machine guns, 360-degree situational awareness, and hunter-killer drone capabilities, its possibilities are endless, and recent news of a joint venture with the German Army's Future Soldier system could also have it controlling the skies. European armies introduced the first armored vehicles during World War I, and besides the slow and clunky tanks, smaller vehicles were used to quickly deliver small contingents of troops and supplies to the front lines. During the post-war period, Germany developed a new war doctrine known as the Blitzkrieg, or Lightning War. The doctrine called for the use of overwhelming force against an enemy, and one of its most essential elements was using tanks and mechanized infantry to strike behind enemy lines and swiftly destroy anything in their path. The Wehrmacht put the doctrine to good use in World War II with a series of armored infantry vehicles that were quick to put Panzer Grenadiers, or mechanized infantry, where they were needed the most. Then, when the mist of the Cold War engulfed Europe in a fight between democracy and communism, the new German armed forces, the Bundeswehr, developed a new infantry fighting vehicle that could also carry men into battle. It was named the Marder, or Martin Infantry Fighting Vehicle, and it was introduced as the primary weapon of the Panzer Grenadiers. After that, it became the top companion of the Leopard 1 and Leopard 2 battle tanks within the German army. Development of the Marder began in the 1960s, but the first units weren't delivered until a decade later. Like the American Bradley fighting vehicle, the Marder features the conventional design of an infantry vehicle. It is 6.79 meters long, 2.98 meters high, and has a width of 3.24 meters. Depending on the variant and armament, it can weigh between 28.8 and 37.5 tons. The IFV is manned by a crew of 3, a commander, a gunner, and a driver, while the passenger section has space for 6 fully armed Panzer Grenadiers. Its main armament comprises a 20mm Rheinmetall Mk20 RH202 automatic cannon with 1,200 rounds, and the secondary one includes a 7.62mm MG3 machine gun with some 5,000 rounds. Also, the Marder is powered by an MTU 8B8333 EA500 diesel engine that allows it to reach a maximum speed of 75 km per hour with an estimated operational range of 520 kilometers. Still, despite its excellent combat capabilities, the Marder did not see combat for over 38 years. It wasn't until July of 2009 that several Marders got a taste of combat when they defended a German army outpost from the Taliban in the Shahar Darah district of Afghanistan's Kunduz province. However, the German army had begun to look for a replacement for the Marder as far back as 1996, as the IFV was already showing its age. It was then that the army found the Puma under the Neue Gepanzerte Plattformen, or New Armored Platforms project. This vehicle would become the next-generation infantry fighting vehicle for the Panzer Grenadiers. In 2002, under a joint venture between Rheinmetall Lynx System, Krauss Maffei Wegmann, and manufacturer Projekt System and Management, the German Federal Parliament authorized the development of a successor to the Marder. 5 prototypes were ordered by the Bundestag, and the first one was rolled out in December of 2005 for internal testing. The design was inspired by a new tactical concept called Neue Schützenpanzer, or New IFV, but it was quickly dubbed the Puma after the animal's agility and ferocious nature. The first fully functional Puma was delivered in 2006 and was followed by the other 4 in 2007. After intense army trials, the first Pumas entered service in 2015. Currently, the German army has over 350 Pumas in service and is expecting another 230 by mid-2023, with Canada, Australia, and other NATO partners as potential buyers. Like the Marder, the Puma has the standardized look of an armored infantry fighting vehicle, or AIFV. It has a length of 7.6 meters, a height of 3.6 meters, a width of 4 meters, and a weight that varies between 30 and 40 tons, according to armor and armament modifications. The Puma incorporates several state-of-the-art technologies that make it stand out from other IFVs. One of these lies in the ability to flexibly mount different layers of armor. It also has a crew of 3 and can accommodate up to 8 infantrymen in the rear compartment, which is air-conditioned. A rear-powered ramp allows the men to quickly get out. The vehicle is designed to accommodate 3 interchangeable protection classes. The most basic one, simply dubbed Class A, gives the vehicle its standard weight of 31.5 tons. Protection Class B was meant for transport by rail, and it incorporates 2 large panels that cover the entire flanks of the vehicle and work as skirts for the tracks. In addition, another armor cover protects most of the turret and the Puma's roof. Finally, Protection Class C has the same armor protection as Class B, except that it is not meant for transport by rail. This protection increases the Puma's weight to 43 tons, making it heavier than the Russian T-72 main battle tank. The overall vehicle is protected by AMAP composite armor, which protects kinetic threats and shaped charges, and 14.5mm rounds from Russian heavy machine guns are no match against it. The armor can also withstand the blast of 10-kilogram heavy mines and fire from heavier 30mm rounds. The vehicle also bolsters improvements in situational awareness, as it features a 360-degree periscope with 6 different zoom levels. This device is located in the turret center and can be used by either the commander or the gunner. It is also linked to the onboard computers and 5 other external cameras that feature thermal vision and different zoom levels. Puma's armament comprises a 30mm Mk30 autocannon with 400 rounds, one 5.56mm HK MG4 machine gun that can be replaced with a 7.62mm MG5, and a Spike LR anti-tank guided missile launcher to get rid of any air threat. Moreover, the Puma also carries smoke grenade launchers and a 76mm launcher located at the rear for defense against any flanking maneuvers. All of the weapons can be operated remotely. Additionally, the back door can be opened halfway to allow 2 soldiers to fire with moderate protection. And despite all the firepower and armor the Puma carries, it can reach speeds of up to 70 km per hour with an operational range of 600 km, thanks to its efficient MTU MT892 KA501 diesel engine. In March of 2012, the Puma was tested under Arctic climate conditions with great success, managing to keep its crew warm and making its way through the landscape without any issues. Then, in October of 2013, the IFV was tested under hot climate conditions, and it emerged victorious, proving its versatility in different combat scenarios. 6 years later, the German army awarded more contracts to upgrade the Pumas to the System Panzer Grenadier, or VJTF 2023 project. This package intends to link the Puma IFV to the German Army's Future Soldier or Expanded Soldier system and fuse them in a networked combat environment to bolster battlefield effectiveness and coordination. As part of this program, the companies involved are also developing a hunter-killer functionality so that the Puma's crew can get direct control of swarms of drones or unmanned aerial vehicles for a reconnaissance or combat scenario. If all these capabilities are successfully integrated into the Puma, there's a high chance that it will become one of the most effective and technologically developed armored infantry fighting vehicles in the world. After over 40 years, Germany is finally bringing more firepower to its tank program. In 2022, Rheinmetall Defense unveiled its bold new creation, the Kettenfahrzeug 51, a lightweight tank expected to set new standards in lethality, survivability, and mobility. Also known as the Panther, the main battle tank is bristling with all the most up-to-date technology in the market, including a much larger main gun, a digital computer backbone, and a state-of-the-art suite of defensive features. After stunning more than one at a military hardware show in Europe's Eurosatory defense exhibit, the tank prompted much speculation and controversy, leading many to wonder if it will replace Germany's current tank arsenal, if it will be used only for exports, or even if such a tank is needed at all in today's world. It's rare when a new tank, tracks and all, appears on the warfare market. As such, when Germany announced the creation of a new main battle tank for the first time in over 4 decades, the crowd at France's Eurosatory Arms Show went wild. During the June 2022 event, a biennial showcase for Europe's arms manufacturers, to promote and announce their latest technology equipment, Germany-based Rheinmetall showed off a prototype of its newest creation, the KF-51 Panther. The name is reminiscent of the elusive Panzer Kampfwagen 5, designed in 1942 and used to counter Russian vehicles like the T-34 in the Eastern and Western fronts from 1943 to the war's end. Some of the medium tank's most significant feats took place in battles such as the Normandy landings and the Battle of the Bulge. Despite being one of the most effective German tanks at the time, the Panther was severely hobbled by mechanical and reliability issues. Rheinmetall's KF-51, however, is the successor to the Leopard 2, a 1980s contemporary American M1 Abrams tank vehicle. Despite making its debut 40 years ago, the model remains in service with more than a dozen armies worldwide and is constantly being upgraded. But like many modified systems, there comes a point when it becomes impractical and exceedingly expensive to keep adding new technology. The only way to move forward is to design something new, and according to Rheinmetall, the KF-51 is here to make the transition as smooth as possible. In a hype video for the new tank, Rheinmetall calls the Panther an apex predator and the future of so-called tanknology itself. Featuring a gray, black, and neon yellow camouflage pattern, the KF-51 Panther is a radically new technology-forward main battle tank concept. According to Rheinmetall's official website, the Panther tank was designed from scratch to deliver the highest lethality on the battlefield, drawing on some of the world's latest technology. The vehicle is being built to be a fully digitized system, meant to control assigned unmanned aerial vehicles such as drones, loitering ammunition, and a wide range of uncrewed ground vehicles. One of the most interesting features about it is that it weighs just 59 tons, a relatively slight tonnage by modern standards. In contrast, the American M1 Abrams weighs 73.6 tons, without all the more prominent features like guns and munitions. The company adds that the new features will make an agile, maneuverable, and sprightly tank. In addition, the tank's engine will be the same 1475 horsepower diesel engine that the Leopard 2 uses, giving the Panther a range of 310 miles and a rumored maximum speed of 40 miles per hour. While the Panther's chassis draws on components of the Leopard 2's hull, the turret and state-of-the-art defense systems are entirely new. Meanwhile, the tank's main armament is the company's own 130mm cannon. Designed for the main ground combat system program's future gun system, the cannon is automatically loaded from 2 revolver-type magazines with 10 rounds each. The company claims that this weapon has an unrivaled rate of fire because of the programmable airburst ammunition, which can also fire kinetic energy rounds. The weapon is also complemented by a 12 7mm coaxial machine gun, a stark contrast to the 7.62mm coaxial one that equips almost all main battle tanks today. And Rheinmetall's own 7.62mm remotely controlled weapon station, known as Marder, is positioned at the rear of the turret roof. All weapons are controlled electronically, and laser rangefinders give the Panther hunter-killer capabilities. Plus, the Panther tank has a 3-layer self-protection system to protect crews on the battlefield. First, there's an active layer to protect it from anti-tank missiles and other kinetic energy-related threats. Second, a reactive layer to neutralize double-shaped charge rounds that may still get through. And finally, a passive layer of steel composite armor to stop any remaining elements. The Panther tank was designed to be operated by a 3-person crew, with the pilot positioned in the chassis and the commander and the gunner in the turret. All the team members can handle the sensors and weapons, as each operator station can assume the tasks and roles of others while retaining full functionality. And if needed, additional space in the chassis can work as either a command post or for a drone operator or wingman pilot. Given that the turret and weapons can be controlled from the operator stations near the chassis, it opens the opportunity for future Panther variants with unmanned turrets, and perhaps even a fully remote-controlled version. The driver is provided with a hatch, and it appears as though the optional crew station for the potential 4th crew member can also be fitted with a hatch. Even so, one potential downside of the Panther, first noted on the Eurosatory demonstration, is that the driver and additional specialists have no convenient emergency exits. Such a scenario could be affected by the slope-turn turret armor that often overlaps the hatches, creating a potentially severe survivability problem if the crew members are ever trapped in a burning tank. According to Rheinmetall Defense, the Panther Kettenfahrzeug KF-51 will be a game-changer on the battlefields of the future, and the new model will set new standards in lethality, protection, reconnaissance, networking, and mobility. Despite seemingly being built for an exact purpose or requirement, John Philip Weiswanger, the company's assistant head of public relations, claims the Panther's design came entirely from Rheinmetall's pockets and not in response to a client's request. The spokesperson confirmed that the vehicle is not a candidate for the Franco-German main ground combat system project, famously launched in 2012 to replace the Leopard 2 and Leclerc main battle tanks, but instead has the export market in mind. Looking at the market and those who use two vehicles, potential buyers of the KF-51 include Austria, Canada, Denmark, Greece, Hungary, Indonesia, the Netherlands, Norway, Poland, Portugal, Qatar, Spain, Sweden, Turkey, and Jordan, among others. And yet, the Panther is only the beginning. In the near future, the company also plans a family of complementary vehicles that will push innovations that support environmentally friendly peacetime operations and further optimization in automation and effectiveness. The Panther is also expected to change as its development moves forward, and company directors want Rheinmetall and all logisticians and procurement professionals of future users to have an active voice in shaping the future of the vehicle. However, the tank has many doubters who question whether a new tank like this is even needed in today's environment. And as impressive as it sounds and looks, it will undoubtedly be an expensive endeavor. Even so, the KF-51's new innovative features and more powerful gun are beyond what the West's current and dated crop of tanks can bring to a mid-21st century battlefield. Only time will tell the level of influence it will have on worldwide warfare technology.